Hi everyone, and welcome to your first set of video notes for task 1.1. This will get you ready to do the ready, set, go for this task. So to get ready here, we're going to talk about some vocabulary first. So the first vocab term we have is the solution to an equation. So the solution to an equation is a value that makes an equation true. So for example, if we look at this equation x plus 3 equals 7, we can do some mental math and we know that 4 is the value that's going to make this equation true. So our solution is going to be x equals 4. So in the ready, what you're going to be asked to do is to identify which of two different given values is the solution to the equation. So here's what we're going to do. In order to find out which value is a solution to the equation, we're going to take the value of x that they give us and we're going to plug it in to x in the equation. So here's how that would look. I'm going to copy down the equation, except instead of the x, I'm going to put some parentheses in. And I'm going to substitute that x with the value of x that they gave me. And everything else I'm going to copy down. And so my question here is this actually equal to 7? And to find out, I'm going to go ahead and use my calculator. I highly recommend using a calculator just so we don't make any arithmetic mistakes in our head. And I'm going to type this in exactly how I see it on my paper. So I'm going to type in 3, I'm going to type in my parentheses with -2, and then -2, and I'm going to hit enter. That gives me a value, when I enter this in my calculator, of -8, which I know is not equal to 7, and I just showed that with an equal sign with the line through it. So x equals -2 is not a solution because it did not make a true statement there. So now we're going to try x equals 3. And just like before, we're going to substitute 3 now where we see x in our equation. So I'm going to, again, copy my equation, except I'm going to put a set of parentheses where I had the x. Everything else I'm going to copy. And in place of that x, I'm going to put a 3. Again, our question is the same here. I'm going to put a question mark. When I simplify this in my calculator, I want to see if it's actually equal to 7. So again, I'm going to use my calculator and I'm going to type it in just how I see it on my paper. In that case, I actually do get 7 out, which is equal to 7. That is a true statement. It makes the equation true, so I know x equals 3 is a solution. The next thing we need to be able to do is work with ordered pairs. So an equation can be used to show the relationship between two variables. And we show that these numbers are related using ordered pairs. So for example, the following equation shows a relationship between two variables. So my equation might be y equals x minus 1. That tells me the relationship between my variables x and y. An ordered pair might be 5, 4. So now our job is going to be to find the missing values in ordered pairs. And we can find those missing values using the equation. So a problem might look like this. Determine the y value of the ordered pair based on the given x value. So this is going to work a lot like what we did above. We're going to be substituting a value in for x. So when we look at an ordered pair takes the form x comma y. So in my ordered pair here, what they did is they gave us a value of x. In order to find the y value, right, that's what we're missing here, we're going to take this x value of 3 and we're going to substitute it in for x. So this idea of substitution is going to be important for these types of problems as well. So now to get the y value, I have y equals, just like above, I'm going to copy in my equation, leaving a space for that x. I copy in everything else. In place of the x, I put in a 3. And just like before, I'm going to use my calculator to make sure I get this calculation correct. I'm going to type it in exactly how I see it on my paper using those parentheses. So -2 times 3 plus 5. And that's going to give me a y value of -1. So in my ordered pair, it's going to be 3 comma -1. And that's the y value of my ordered pair. Okay, so now we're going to switch and we're going to talk a little about reading a story or a word problem in math and how we find the important information in those word problems. So when we're reading a story problem in math, it's important to look for 2 pieces of information. And you might want to use colors here. I'm going to use 2 separate colors so then when we look at problems, we can highlight this information in those colors. So the starting amount, I'm going to say that is the amount that happens one time. That's going to be one really important piece of information. What's the amount that happens one time? Now, our pattern, on the other hand, is going to be the amount that repeats. Okay, so that's going to happen over and over again. And it's going to tell us how the starting amount increases or decreases. So it tells us how that starting amount is changing, whether it's increasing or decreasing, and that's a decision we'll have to make by reading the problem. So let's look at some problems and see if we can pick out these 2 pieces of information. So our job is going to be to fill in the table using the information and then write a sentence explaining how we figured out what values to put in each space. So here's my problem. You run a business making cell phone cases. You spend $800 to start your business and it costs you $4 to make each phone case. So if I go back, I know my job was to find 2 really important pieces of information. The first is the starting amount, so the amount that happens one time. So in my problem, I notice it says I spend $800 to start the business. So one time to get my business started, I have to pay $800. So that's my starting amount. Okay. Now, for the pattern, that's the amount that repeats. In my problem, it tells me it costs me $4 to make each phone case. So each time I make a case, I have to pay $4 more. That's going to repeat, so that's my pattern. So I'm going to use those pieces of information to fill out my table. Now, the most important thing to fill out or notice here is for the number of phone cases, it starts at the first phone case, but sometimes I think it's helpful to start even back at 0. So I'm going to add in a column, and this may be a strategy that helps you with these problems. So for me, I know that even if I make 0 phone cases, it still cost me $800 to start my business. So my total cost, even though I've made nothing, is $800. And I know that's small, but that's where my starting amount is going to go. Now, to make my first phone case, it told me it's going to cost me $4 to make each case. So to get from here to my first case, I have to add $4. So to make one phone case, it's $800 to start plus the $4 to make the case. So my total cost is going to be $804. Remember that 800 was one time. My pattern, the repeating amount, is $4. So from there, to get the next value each time, I'm adding $4. So 804 plus 4 gives me 808. And I'm going to keep up that pattern of adding $4. So I have 812. 816, 820, 824, and 828. I just added 4 each time. So now when I'm asked to explain how I filled in my table, I need to make sure I'm talking about the starting amount and that repeating amount, the pattern. So to fill in the table, right, I started with it costs $800 to start plus $4. So I started with $804 for the first phone case. Because the starting amount was $800. And I'm going to put that in pink just to keep reminding us. The starting amount was $800 plus it cost $4 to make the case. And then after that, to fill in the table, I added $4, that repeating amount, each time. Okay, now the idea here is I don't want you to be so worried about copying these exact same words, but the idea is you have to be able to reference your initial amount and then talk about that repeated cost that you used to fill in the table. All right, for number 2, same idea here. So let's read through our pattern and find out those pieces of information. So we make a $300 payment on our car loan of $5,000 at the end of each month. So when I'm talking about that starting amount or the amount that happened each time, I know I'm starting with a loan that's $5,000. That's my starting amount for my loan. Each month, I'm paying $300. That's repeating each month. Now, the one thing I have to be careful of is if I owe $5,000 and I'm paying $300 each month, the amount of my loan is going down. In this case, I have a decrease. So I have to make sure instead of adding like we did before, that we're subtracting. So again, for me, it helps to think about, let's say 0 months have gone by. I know that the amount of money that I owe and I'm going to put it sideways, apologize for that, is $5,000 because I haven't made any payments yet. But now, so for the first month, I know I'm going to make a payment of $300. So to find out how much I still owe, I'm going to subtract the $300. And again, we're working with numbers that might be a little trickier here. I'd recommend pulling out your calculator. We have 5,000 minus 300. That gives me $4,700. And then again, I know the next month I make another payment. So the amount I owe is going down by $300. That amount I owe is decreasing. If I subtract 300, now I owe $4,400. And I can keep that pattern up all the way along this table. I'm decreasing it by $300 each time. So we'll go ahead and fill those in. Okay, we're going to keep subtracting 300. And we get 2,900. Again, using that calculator to make sure we don't make any calculation errors. Okay, so explain how we filled in their table. Okay, so after 1 month, I owed $4,700 because the starting amount was $5,000. I'm going to put that in pink to make that connection there. But I made a payment of $300. So I subtracted that. Okay, to complete the table, I subtracted, I'm showing that it's decreasing by subtracting. I subtracted that same repeating amount, $300, for each month. Again, what's important here is that you're referencing that starting amount that you picked up from the problem and then how that pattern affected your table. Okay. The last thing we need to talk about is some vocabulary around graphing an ordered pair on a graph. Okay, so we can graph ordered pairs to show their relationship. Ordered pairs have both an x-coordinate, so you'll hear us use the words coordinate a lot, x-coordinate, and a y-coordinate. Now, the x-coordinates are always going to tell us how to move left or right, and the y-coordinates tell us how to move up or down. Now, the important thing to note when we're plotting a point, when we're graphing ordered pairs, is we're always going to start at the origin. Okay, so for my first ordered pair here, I have an x and a y coordinate. Because my x-coordinate is a positive 2, it's telling me, starting at the origin, to go right 2. Now, because my y-coordinate's negative, that's telling me to go down 3. So to plot this point, I'm going to start at the origin, go right 2 and down 3, and plot my point. So the ordered pair is just a set of directions to get you to that point. On the other hand, here we have -2, 3. In this case, my x coordinate's negative, so that tells me to go left. My y coordinate is going to tell me to go up because it's positive. I still start at the origin. I'm going to go left 2 and up 3 and plot my point. Now, we'll leave number 3. We can talk through that when we're back in class. So please at this point just make sure you have complete notes and have marked any places where you might have a question that you need to ask at the beginning of class. So thank you for being responsible and taking complete notes, and we'll see you back in class.